This video demonstrates the software setup and data analysis procedure with respect to the Agilent gas chromatograph in the Unit Operations Laboratory at Lafayette College. When using the GC, proper safety precautions should be taken. Care should be taken when opening the compressed gas tanks. If improperly handled, the tanks can serve as projectiles. Only the main valve should be used to open the tanks. The regulator valves should only be adjusted by laboratory supervisors. Proper personal protective equipment should be worn when handling any hazardous chemicals such as gloves, safety glasses, and a lab coat. To start up, start the computer to access the Agilent GC software. Open the online version of the EasyChrome software. Open the valves of the gas tanks located to the left of the computer and ensure the regulated pressure readings for helium and air read 80 psi and the hydrogen tank reads 40 psi. If the tanks need to be adjusted, contact the laboratory supervisor for help. Check that the minimum solvent level is present in the wash vials. If the vial needs to be filled, put on gloves and a lab jacket and fill the vials with acetonitrile in the hood. Next, turn on the Agilent GC by pressing in the button on the front and allow it to cycle completely through its startup. In the EasyChrome window, go to File, Method, Open, and select the desired method file located in. Open the file. Once open, go to Control, then press Download Method to send the settings to the GC. Go to Sequence, New, to create a new sequence. When creating a new sequence, the following cells must be filled in correctly: reps, sample ID, method, and file name. Each sample ID and file name should be unique to each trial to avoid writing over a previous trial. File name should be completed automatically with .dat. Previously created methods can be chosen using the drop-down menu on the cell. Continue for each trial in the sequence. Save the sequence by going to File, Sequence, Save As. Save to the file location. In order to develop new method files for each trial, the parameters of oven temperature, ramp rate, and gas flow rate will be changed. It is easiest to modify an existing method that has been shown to work. If you do this, go to Method, Save As, and rename the file so that you do not overwrite the original file. To change the oven temperature and ramp rate, click on the oven icon. The initial oven temperature and ramp rates can be changed by clicking in the appropriate boxes. In the CFT settings, the gas flow rate can be adjusted by typing in a different flow rate. In the Signals tab, be sure the FID is highlighted and the parameters are set to 50 Hz, and save in order to make sure a signal is collected for each run. When done modifying the method, be sure to go to File, Method, Save, or Save As, if you have not already named the file. Prior to starting the sequence, check that the GC has gone through the startup cycle by checking the status. On the GC interface, press the Status button. Wait until it says Ready to start a sequence run. If there are any errors, contact the laboratory supervisor. Change the LIT offset from 2 to 0.5 on the GC interface by hitting Config, scrolling down to Front Detector, then changing the LIT offset to 0.5 on the keypad. Now that the GC is ready to run the sequence, it can be started by going to Control, Sequence Run, Start. Do not by any means stop the GC before it has finished, because the last 4 minutes of each run are used for cleaning the apparatus. Failure to do so will cause contamination and possible problems with the GC. In order to shut down, close and exit the EasyChrome software. Run the cooldown method. Access the method via the keypad on the Agilent GC by pressing Load, Method, 1, Yes. Allow this method to operate for 5 to 10 minutes and allow the oven and GC components to cool. Check the temperatures via the GC keypad. Press the oven and detector button to check the temperatures of the components. Turn off the Agilent 7890A using the button on the front of the machine. Close all gas cylinders. To analyze the data, open the chromatogram by opening the offline version of the EasyChrome software. To view a chromatogram, go to File, Data, Open. To view the analytical results, go to Reports, View, Area %. To print a report for the selected data file, you can create a PDF by going to Reports, Print, Area %, and then selecting Adobe PDF as the printer. Each peak in the analysis will have its own retention time. In the case of methanol water solutions with an isopropanol internal standard, the first peak will be methanol due to its lower boiling point. Peak areas for both the analyte, methanol, and the internal standard should be recorded along with their respective retention times for all chromatograms obtained. To calculate the concentration of an unknown methanol water sample, the specific relative response, or SRR, must be calculated using the standard curve. For more information on the standard curve development, see the related GC video on the Lafayette CHBE YouTube channel. The SRR is calculated using the equation where SRR is the specific relative response. A sub A is the area of the analyte, A sub IS is the area of the internal standard, C sub A is the concentration of the analyte of interest, and purity analyte is that of the methanol. Plot the SRR versus known concentrations to create a normalized plot. The points should have a horizontal linear relationship, or a slope of 0. The weight percent of the analyte can be determined using the equation. The concentration of the sample is determined by massing the amount of sample added to a 50 milliliter volumetric flask, and the purity of the analyte is the purity of the methanol used in this case. This analysis will be used for both the vapor-liquid equilibrium and distillation experiments in the unit operations laboratory. To learn more about the operation of the gas chromatograph or the applied experiments, watch the related videos on the Lafayette CHBE YouTube channel.